The Jones family have just bought a new GEC television set. They are delighted with it, and they will be just as pleased in the years to come, because the GEC have been using new and ingenious manufacturing techniques which ensure the greatest reliability possible in the complex circuitry of a television receiver. At the GEC Radio and Television Works in the heart of Coventry, new production lines are turning out many thousands of receivers per week, unequaled for their quality. This film will show some of the processes built into the receiver and how these lead to exceptional reliability and reception. The backbone of the new receiver is a pair of printed wiring panels. The material for the panels, which is copper-clad laminate, arrives in large sheets. These are guillotined accurately into long strips, taking care not to damage the thin copper film. These are then cut to the size required. Indexing holes are punched, leaving the panels ready for feeding into the subsequent processes. Feeding from a magazine, the panels travel under scratch brushes which clean the surface and are then sprayed with a light sensitive coating. After the coating has been dried, the boards are put into the printing machine and carefully brushed to remove particles of dust. The negatives are located by means of the indexing holes. Accuracy is needed in this process since the component insertion holes must be aligned to the copper conductors. A vacuum-operated plate holds the negatives in close contact with the panels whilst they are being exposed to an arc lamp for several minutes. The panels are developed by dissolving the unexposed coating. The remaining image will act as a mask to an etching solution, which removes unwanted copper from the panels. The boards are seen traveling to and from the etching machine. The continuously moving conveyor carries racks of panels through an etching zone where the panel faces are sprayed with an etching solution. The coating remaining on the copper effectively masks the wiring that is wanted, whilst the unwanted copper is removed. Thorough washing follows and the boards are then dried. After unloading, they are date-coated and the 300 component insertion holes are punched in one operation. In order to assist the service engineers, component titles are printed by a silk screen onto the reverse of the board. Different colors are used to identify the various panels passing through the plant. Selective soldering is achieved by a further process which applies varnish to parts of the copper surface where no soldering is required. The completed boards now pass through a stringent inspection. Scrutiny for possible imperfections and pinholes in the copper circuit takes place. Only perfect boards progress to the main assembly lines. The others are scrapped. This inspection is typical of the many which ensure that the minimum of faults appear for clearance later in the production line. The GEC television receiver is manufactured on an automatic production line which is fed by several supply tracks. These tracks start with the basic components and move continuously, collecting components and making sub-assemblies for feeding to the final assembly line, which delivers the complete and tested receiver. This machine is typical of the two lines for the automatic insertion of components into the printed wiring panels. The panels are fed from magazines at the start of the automatic assembly track, their rate of operation being controlled from the central control unit, which will be seen later. The panels are moved along automatically and index themselves under the insertion heads. Here, a valve holder is being inserted and locked mechanically before the panel indexes to the next position, where a similar operation is carried out. Each of the automatic insertion heads is fed by a magazine of components. When a magazine is empty, it is easily removed and replaced by a full one. A resistor is being inserted and stapled to the board. The machine cuts the leads of the components it inserts so that they protrude through the panels to a depth suitable for soldering in the dip solder bath. This magazine is controlled, again from the central control unit, so that panels are released at the correct rate to the manual insertion line. After a preliminary inspection, the remaining components are fitted to the board manually. The operator can be seen using a thimble to turn over the ends of the leads of the components she has inserted. In the main, only components unsuited to automatic handling, such as transformers and capacitors, are fitted in this way. The panel is inspected again and is now ready for dip soldering. Flux is sprayed on the panel as it enters the unit. The carriers ensure that the board floats over the surface of the solder. Since the wiring has been masked, only the joints themselves are soldered. Thus, one operation replaces the many separate operations of soldering individual components which were formerly necessary. The resulting panel is tidy and very reliable. The quality of the soldering is examined, and two strengthening strips are added to give the panel a means for attaching it to the frame. It can be seen that the trays on the conveyors are painted in different colors, which enables the operators to identify quickly the particular sub-assembly they require. A final inspection of the panel and all the components which have been added to it both automatically and manually is made before the addition of valves, which completes the unit. The panel is now tested on a conveyor system which indexes in a similar fashion to that of the assembly lines. Routine electrical tests are performed, and in the case of this IF strip, alignment procedure is carried out. A card is attached to the test unit, and if a panel fails any test, the card is punched to indicate the locality of the fault. Whilst the completed panels circulate on the overhead conveyor until they are required at a main assembly station, faulty panels pass to the troubleshooters for correction. Altogether, 4 conveyors supply the assembly lines. The flow of each assembly line is regulated by this central electronic control unit. It ensures that each sub-assembly line works at the same speed as the main assembly line. Auxiliary tracks provide cable forms, mains leads, and other components. The matrix on which the cable form wires are set is indexed throughout its various operations and returns automatically to the start of the track when the form has been completed. The vast majority of the interconnections between panels and other components is built into a single cable form. As with all components feeding a mechanized line, the lack of one type of wire could disrupt production. Advanced methods of material and production control make such hold-ups very rare. After inspection, these auxiliary components travel on an overhead conveyor to the appropriate stations on the main assembly line. The 3 parallel tracks comprising the main assembly line are served by the overhead conveyors. At the start of each line, there is a riveting section where the receiver frame is assembled and riveted. The frame shows little resemblance to the older form of chassis, a direct result of the intelligent use of printed circuits. Components are attached as the frame progresses down the track at a speed determined by the main control unit. Here, the cable form is being attached, leaving a number of plugs to be fitted into sockets on the panels. Finally, the 2 printed wiring panels are fitted in the receiver. Printed wiring ensures accurate mass production of circuitry and reliable and easily serviced television receivers. Here is the cathode ray tube conveyor. After the protective bag is removed, the tube is fitted into the frame. The alignment jig ensures that the tube face is correctly positioned relative to the frame, so that when the chassis is placed in the cabinet, the tube face will fit snugly into its surround. The completed chassis passes to an insulated indexing track and is tested for insulation. Power is now applied from overhead rails, and the receiver passes through a series of comprehensive tests using signals generated within the factory to check the overall performance. This procedure gives a preliminary aging, referred to as a soak. No attempt is made to correct faults on the main production line. If a receiver fails, it is automatically transferred by lift over the main tracks into the repair area. When the fault has been located and corrected and the receiver retested, the set is returned to the first vacant position in the line. A general view of the final clearance area. On the left is one of the automatic lifts. In the background, the lines extend for nearly 300 feet. Careful cleaning ensures that no specks of dust remain which might tend to spoil the vivid picture. The ease with which the receiver chassis can be fitted into the cabinet makes the final assembly of the set very simple. It is reconnected to the overhead mains for a final check. Automatic lifts again take faulty receivers to the repair area and return them after correction. The back panel is fixed on using a pneumatic screwdriver. Most of the tools on the lines are pneumatically operated, and wherever practicable, jigs are used to make assembly easier. After a final polish, instruction booklets are added and the set is registered. The completed receiver then passes through the packing area, where methods are also aimed at speed and ease of handling. Until it has been sealed in its carton and is being sent to the dispatch area, the set has never been lifted by hand. The design of the cartons in which the receivers are dispatched is carefully controlled and subject to stringent tests. Each model in its carton is dropped from a specified height onto a concrete floor on all its 6 faces in turn, and types of packing which fail to give complete protection are rejected. Completed sets leave for dispatch to GEC dealers all over the country. Behind them is a wealth of engineering ability. Ahead, many years of reliable television reception. GEC television receivers are famous for giving vivid picture truth. In a way, this film has told the vivid picture truth behind the skilled engineering and the rigorous testing at all stages of manufacture that are making the latest GEC receivers the best of today's television. You have seen just one aspect of the GEC approach to modern techniques in electronics. The Jones family indeed have good cause to be happy with their new set, confident in the thought that it will remain trouble-free for years to come.